Hello, my name is Jaak Tepandi, and this is a short summary of static analysis for our software quality processes and standards course. We discuss what is static analysis, why it is needed, what are its disadvantages, types such as walkthrough and so on, and some tools such as questionnaires, standards, and so on. Importance of static analysis was understood after several accidents. One of the most known of these is the accident with Terak 25, where several people died as a result of massive overdoses of radiation. When this incident was analyzed, it came out that to have this incident, the operator needed to input a particular, very non-standard sequence of keystrokes. The speed of this input was important, and there need to be an arithmetic overflow. It would be very, very difficult to discover this these errors in this program through testing, or actually we might say that it was a kind of testing, but obviously not the kind of testing we would like to see. Another source for need for static analysis comes from economic considerations. Errors are the more expensive the earlier they occur on system development. So the earlier we get these errors, we find them, the better. In the early stages, when we have just the system idea, or perhaps preliminary requirements, we do not have the system itself, so it's difficult to do testing. Of course, we may have different kinds of prototypes, but they do not reveal the main requirements to the system. So prototypes are still insufficient to test, for example, important non-functional requirements. So we need some methods and tools besides software testing. Static analysis is such a collection of methods and tools. So it's analysis of software artifacts. They may be requirements, code, other documentation, carried out without execution of these artifacts. It enables early discovery of errors. It's useful because testing cannot cover all possible situations, because the reliability gained with testing has limits, and because several important system qualities such as maintenance and others are difficult to evaluate by testing alone. As everything, static analysis has its drawbacks. First, it doesn't replace testing, and it requires time, coordination, and it may involve possible negative side effects. So, examples of static analysis arrangement includes analysis by the author, walkthrough, and some others. We could include some strong methods such as program proofs, simulations in the static analysis, but in the current course we restrict ourselves to usual walkthroughs, analysis, and so on. There are different types of static analysis, such as contract review, design walkthrough, code inspection, and others. We will have a look at the walkthrough and different tools such as questionnaires, standards, automated tools. A simplest arrangement recommended for almost all kinds of development is analysis by the author, because it finds errors, it's cost effective, and if it's not used, it should be trained. But as all methods applied by the author of the product, it's insufficient. It's not sufficient because the author follows own logic. The author is motivated to finish and maybe not motivated to destroy own work. So more powerful methods such as walkthrough can be used. We introduce walkthrough for software development, but actually the setting that is considered here is not only useful for software development, but for many kinds of meetings as well. We may all have attended meetings where nobody knows what is discussed, what are the expected results, who will discuss, and what is the reason for this meeting. So a walkthrough is a formal software peer review in which an author of some product, such as designer or programmer, leads the development team and other parties through the software product, and participants are asked questions, make comments, errors are discovered, and decisions are taken. Precondition for a successful walkthrough is that all group members should have expectation of what they are expected to do. So if there is no such an expectation, there should be some training before conducting a walkthrough. There should be good cooperation, otherwise walkthroughs are not successful. There should be some materials available and sent before the event, and participants should have some preparation. For example, everyone should have one negative, one positive comment about these materials. There are several participants, such as presenter, who is usually the author, but not necessarily the coordinator of the walkthrough or the manager, secretary who takes notes, members, team members, standards expert, users, representative. And these roles can be combined, so one person can take several roles. What is not recommended, management participation is not recommended. And the reason is that the goal of the walkthrough is to find errors to improve the product, not to influence the salary, for example, of the participants. So, as a recommended arrangement, as many preparations as needed, as few as possible. As usual, we don't want to do excessive, unnecessary work. Recommended length from 30 to 60 minutes. An important recommendation is to analyze the product, not the author, because the goal is to improve the product. There should be a plan, and this plan should be followed. So that's the role of the walkthrough coordinator. There should be some focus. We do not try to solve all the problems. Written notes should be taken. Otherwise, people meet, depart, and on the next meeting will repeat again the same and same discussions. Number of participants should be not too small, not too large. The questionnaires or some other tools for each product should be prepared. All these static analyses take time, take resources, so these resources should be reserved. We cannot think that the people just will gather and discuss. They need additional time. Participants should be trained, and past reviews should be used for learning. Results of a walkthrough are the problems which are found and corrected, a better product or system, a signed protocol of a walkthrough. Depends, of course, also on the walkthrough type, so it's not always, but it's recommended, because then the participants know what was the result and what is expected from them. And changes in the status or wages of the participants usually are not results of a walkthrough. So walkthrough is oriented towards product, not the participants themselves. As an example, in Scrum we have different kinds of meetings. For example, sprint planning, daily Scrum, daily sprint meeting, very short, sprint review about work done, sprint retrospective, and not so often backlog refinement, and coordinating multiple teams in Scrum of Scrums. This arrangement and these arrangements may use different tools. A very useful tool is a questionnaire, if one is available. Standards may be used as questionnaires. We have automated tools such as general code analysis tools for many programming languages, tools for analysis of security vulnerabilities, tools for analysis of accessibility. For performance, we can verify designs. We have tools for program proofs, and we have tools for arranging different events, meetings, and so on. Again, here is an example of a vector found in a popular router firmware code, and this vector included a very specific username, and it's literally impossible to find this vector by testing alone. You need to analyze the code. Different questionnaires as tools for static analysis exist. They have different volumes, from small questionnaires of 10 questions to very huge questionnaires. Then if they have several hundreds of thousands of questions, then it's better to have them automated, of course. Questionnaires may concern different aspects of system development, such as compliance to coding best practice, different application areas, different processes, such as maintenance or acquisition and others, plus automated tools. As an example of a simple questionnaire, in this course we have a look at the coding questionnaire with questions concerning declarations and usage of variables, different errors possible in assignments, in calculations, in comparisons, iterations, calls, input-output, and security. Many kinds of such questionnaires are available, and they are recommended to use in respective of their orientation and usage area. Standards or other good practices may also be well used as a questionnaire or as a base for questionnaire. For example, here is an example based on ISO 12207, which says that the acquirer shall conduct acceptance review and acceptance testing and shall accept it when all conditions are satisfied. The acquirer shall define and document the strategy and accept the strategy and conditions. And we have some very natural transformation of this text into a questionnaire. So we might ask, has the acquirer conducted acceptance review and acceptance testing, etc.? Has the acquirer accepted the product or service when all conditions were satisfied? Has the acquirer defined and documented the acceptance strategy and conditions, and so on? So there are many cases where such standards can be used as a useful questionnaire for reviews, for different types of reviews. So as a summary of static analysis, it's analysis of different artifacts related to software development, maintenance, and other processes without execution. It is very useful because errors are discovered at the early steps, because it's not possible to test all situations, because several important system qualities are difficult to evaluate by testing, and because it significantly increases software reliability and decreases possibility of very serious failures. It has disadvantages. It doesn't replace testing, requires time, coordination, has possible negative side effects, and so on. Some examples of methods include walkthrough, inspection, review, analysis by the author, and some others. Examples of static analysis: contract review, design walkthrough, code inspection, and different tools can be used, such as questionnaires, standards, automated analysis tools, and others. There is a large material on static analysis available, and the materials for our course are available on Moodle. The course is Software Quality, Tarkvara Kvaliteet, and alternate download on teppandi.ee. So thanks for listening, and see you.